Hello, everybody. This is Monica Paolini from Senza Fili, and today we're going to be talking about not just energy efficiency, but how to measure it. This is really a key topic. There is obviously an increased interest in having networks that are energy efficient. But the question is, how do you make sure that they really are as energy efficient as you want them to be, or as you expect them to be? How much energy you're consuming, and how is that energy going to serve you in terms of services, in terms of performance? And in the past, most of the testing and monitoring of network has been focused on performance. You want to make sure, is your network working the way you were expecting, is delivering the performance you were expecting. But increasingly, with the effort in making the networks more energy efficient, so to save on the OpEx, on the energy expenses, and to make your networks more sustainable, you also want to know how are they efficient, how efficient they are, and how can you measure that efficiency. And so today I'm going to talk to Giampaolo Tardioli and Jean Dassonville at Keysight about these topics. Giampaolo Tardioli is the General Manager and Vice President at Keysight, and Jean Dassonville, the Strategy Planner at Keysight, and they're joining me from California. So thank you guys for being with us today and sharing your insights.
Thank you. Monica, it's a pleasure to be with you.
And it's a pleasure for me as well. And before we get started, can you tell us a little bit about your background and your role? Jean, do you want to start?
Yeah, thank you. So yeah, my name is Jean Dassonville. I've been working on Open RAN network, and especially on the ORAN Alliance since the inception of this alliance a few years ago. And the goal has been to bring solutions for the ORAN network and to support the ORAN standard. But as you just said, there is an emerging interest towards energy efficiency. And therefore, one of the challenges that we have seen in the last few months is the interest to measure performance together with energy consumption. And that's one of the areas I've been working on.
Absolutely, and I think you're absolutely right. It's the convergence of the two that is going to be particularly challenging, but also fascinating. Giampaolo, tell us about you.
So I'm a General Manager and Vice President responsible for the network infrastructure business, as well as strategic initiatives for the company. So in the context of the strategic initiatives responsibilities, I'm responsible for ORAN and evolutions of the 3GPP standards going into 6G. So we see energy efficiency as becoming a very prevalent topic in this standard, these conversations. And I believe that it will shape the way the industry thinks about the network infrastructure going forward.
Absolutely, and here we have multiple topics that are really hot. Open RAN, energy efficiency, and increasing performance. And it's really the intersection of all of this that really makes it in a way more complex, but also there are a lot of challenges, but there's also a lot of opportunity to improve our networks. So maybe you, can you get us started to think about to tell us what is the sort of the high level approach to energy efficiency at Keysight?
Well, we look at the challenge of establishing benchmarks for disaggregated network when it comes to energy efficiency has been one of the most critical one, because it really is at the intersection, as you said, of multiple disciplines. It's not only RF domain expertise that needs to be brought to the table, but also computational power characterizations. In some cases, you might have artificial intelligence programs that are trying to optimize the overall network. So how do you measure an artificial intelligence model, and compare performance versus the previous training and session? So there are multiple domains of expertise that are coming into the picture. And as we put that expertise that, in the case of Keysight, we have that breadth of capabilities. we are trying to translate that into specific measurable specifications and benchmark in the standard bodies.
Yeah, so to complement what JP just said is what we see is that the specification for energy consumption and energy efficiency measurement were written at the time where the G0B was not disaggregated. And what we see right now is that as the G0B is migrating to a collection of hardware, building blocks, the radio unit, software components running in the cloud with some level of intelligent control, everything coming from different vendors, the challenge is to put everything together and make that more efficient. From a test and measurement point of view, one of the interesting challenges is that the way you measure some functions might be different from the way you measure other functions. A radio might be measured for spectral efficiency, coverage efficiency, but the virtual network functions might be tested another way. So from a test point of view, what we see is that there is the emerging needs to characterize each one of these building blocks in isolation.
So how is that different? Because, as you say, you want to get the energy efficiency over the overall network. That's the overall goal. But then if there is, let's say that it's not optimal, you're not as efficient as you want, you need to drill down. And so you need to get more at the component level, right? So how do you do that? And how is that different in a disaggregated network with open interfaces?
Yeah, so what you need to do first is you need to characterize the component in isolation. What is the contribution to the energy? And what are the potential gains that you can get if you turn on some energy saving modes, for example, the sleep, deep sleep. And so what is the function or device able to do? Because if you think about radio intelligent control, the intelligent controller will have to make decisions according to what's being possible regarding these devices. So what you see is that to optimize energy, usually you are running through loops where some intelligent control will get telemetry information from these building blocks and activate or deactivate some functions to save energy and only allocate resources where needed. And the challenge here, and what's bringing the test and measurement, is to characterize the loop and make sure that the loop runs in an optimized way.
And this is not something that you can measure in isolation or in a sort of idealized performance environment, because the efficiency is going to depend on the utilization, the load on the network. So it's not something you can do in the lab. Well, you can do it in the lab and get sort of the max load, but in reality, in real deployments, that there's a huge variability.
Yeah, absolutely. We believe that there is a need for in-depth characterization in the lab phase, of course, where we test against some new established benchmark. By the end of the day, it's a dynamic type of behavior that needs to be monitored and adapted, real time. So I think one way to mitigate this lab to live type of transition is to have the capability to have digital twins, if you will, of the network at scale. So you need to have scale and accuracy and capability to trade off between the two. So in the past, there has been some models that have been able to test network before deployment from a loading point of view. But now when you have additional layers of complexity like energy efficiency, the capability to have sophisticated digital twins that can emulate that behavior dynamically, even from an energy efficiency point of view, is going to be critical.
Can you give us an example about how the digital twins would help you here?
Well, I'll give an example, for instance, to borrow on something that is very actual and now, like non-terrestrial networks. You might have situations where you have a network that has to decide when to make a transition from a terrestrial network to a non-terrestrial portion of the network, a satellite, not only on a performance type of considerations, but also from energy efficiency. It might be that at a certain point of the day, it might be more efficient to offload some of the network traffic on a satellite, because that is something that is going to be active no matter what. and save some energy from a terrestrial net. So the capability to model the complex dynamic behavior of the network, it's something that would be requiring some sophisticated at-scale digital twin modeling.
And that would help you to manage the network as well, because if you just can run basically different scenarios ahead of time, it would help you not only to monitor what's going on, but also plan for what to do ahead of time, correct?
Absolutely.
And so, what are you seeing in terms? Is there anything that you're learning when you look at power efficiency and you look at the network and individual components and trying to get all the picture together? Is there anything that you're learning when you are looking at Open RAN versus integrated networks, vertical integrated networks?
Yeah, maybe I can reply to this question. So when you look at the Open RAN network, the first approach is to look at just the breakdown of the functional building blocks of the network, the radio unit, the distribution unit, the central unit, and the radio intelligent controller. But when you think about energy efficiency, you have to go beyond that vision. The first one is that there is a significant contribution of the chipsets that are within those different devices. And those chipsets have built-in energy saving capabilities that needs to be activated. So beyond the function, you have a contribution of the semiconductor manufacturers. Okay, that's the first point. The second point is that between these different functions, the DU, the RU, and the CU, you have networking equipment, and the networking equipment also contributes to the overall energy efficiency. So that means that you have to look at the network from an end-to-end point of view, including the functions of the base stations coupled with the networking infrastructure, and getting insight into the equipment to have also an insight on what is the contribution of the chipsets to the overall performance. So what it means from a test point of view is that it brings a need to set up a collaborative ecosystem where the test and measurement vendors work together with the chipset vendor, the equipment vendor, the cloud, and the function vendor to optimize this energy operation of the network.
And we're going to get more into the details of this, but you bring out an important point, which is the ecosystem. So in a vertically aggregated network, you deal with a fewer number of players, or fewer moving parts, so to say. Well, there are a lot of the elements are still there, but the number of interfaces, the number of relationships you need to have is lower. So how do you deal with that? Does it create a lot more work for you guys because you have to talk to everybody?
Well, I think we definitely see, especially in the early phase of ORAN, we have seen a need for establishing interoperability testing regime. I believe the industry is slowly maturing, but when you go back to energy efficiency, from that perspective, I would say that in the early phase of the technology and standard evolution, energy efficiency was not a prevalent topic. So I think we are now into a phase where we need to move from just looking for interoperability, but also interoperability with a certain level of energy performance. So I would say it does create some additional level of complexity. There is no doubt, but also adds additional level of flexibility that helps to solve that complexity, especially to the point where you can move more and more of the functions of the network towards a software implementation, which has a much faster development cycle.
Absolutely. Now, when we look at, we're clearly early days with Open RAN, there's still a lot to learn here. How do you see that in general, or can you have any sort of initial general learnings about energy efficiency in Open RAN versus traditional networks? Is it more energy efficient, or can it be more energy efficient?
I believe, well, let me go first, John, and maybe you can add some color if that's okay. I believe that, as I said at the beginning, energy efficiency was not on the forefront of the design when it comes to ORAN. So as a start, ORAN type of designs and ORAN type of implementations were not more energy efficient than integrated versions. I think that is something that is more and more becoming part of the standardization process. One of the challenges is that there is some harmonization that needs to happen across multiple standard bodies. 3GPP, ORAN, ETSI, all of them somehow play a role here. So I think, from a network design point of view, all of that has to be integrated. But I definitely see companies making progress in this area fairly fast. So I believe in the longer term, we are going to get to a point where ORAN design could be as energy efficient or even more than integrated, but we are not there yet.
Absolutely, there's a lot of work. Now, in addition to Open RAN, there is the virtualized part. So a lot of Open RAN deployments are virtualized, but you can also have other networks that are not Open RAN, but they're virtualized. So can you tell us a little bit about what is the difference between just having a disaggregated network versus a virtualized network?
Yeah, I can talk about that. So definitely, when you look at the progression of the technology, you are starting from RAN to virtual RAN, where you may have one part of the RAN that is virtualized, but the interface between the building blocks are still proprietary. And then you are moving to the Open RAN, which is usually an architecture where that is not only virtualized, but where the interfaces between the different blocks is also open and enables multi-vendor contribution. Okay, so vRAN is a step towards Open RAN. So from an energy efficiency point of view, what we see is that the mechanisms that are used to optimize the functions in a virtual network can also be applied to the function in an Open RAN network. In fact, there are already some experiments where the vendors of the software functions have power loops that leverage from the capabilities of the cloud processors, the Intel processors, the P state and the C state, to optimize the processor resources according to the need for the functions to operate. And this optimization can take place in vRAN, but the concepts are also extremely applicable to the ORAN.
Absolutely. Now, there's all sorts of different layers here of, again, of complexity and opportunity, and AI is another one of them. So we have Open RAN, we're disaggregated, we can have virtualized RAN, and then we have a RAN that is optimized by AI. But how do we know that AI is actually making things better? Or maybe it's just we're just using more power to get the AI learning going. How do we know that we're doing better at the end of the day?
I think we are just scratching the surface of this. It's a fascinating, for sure, subject. I would say that clearly when you look at the radio intelligence controller portion of the Open RAN network, that's where the opportunities for AI comes into the picture. I think there is quite a bit of research happening. In general, the subject of determining whether a given training session of an AI model has improved versus the previous one, and by how much, it's something that is still subject to quite a bit of development. And I think that's one area where Keysight, through the development of some scaled and accurate digital twins, is looking into bring some innovation and some contributions.
Absolutely. Now, you mentioned before standardization, and so there is a standardization of the interfaces and the sort of the basic, but also there is a lot of work being done in terms of standardizing the way we measure power consumption and power efficiency. Do we have all we need? So, sometimes I hear from operators that they want to compare their energy efficiency to other operators or different vendors. They want to compare their equipment or their software with other vendor software. Are we there yet?
You want to take that, John?
Yeah, I can take that question. So as we discussed earlier, the current specifications, one interesting point is that when you look at the specification, they come either from the 3GPP or the ORAN or the ETSI. And when you start measuring energy efficiency, you have to take into account these different specifications. But as of today, the specifications are not in a state where they provide all the provisions to support the new Open RAN standard. So there is definitely a need and a demand, by the way, to provide to the market the right specification that would help do exactly what you were asking for. That means compare, benchmark, position different elements of the RAN or different combination of elements in the RAN. So definitely there is a strong demand to provide specifications that are agreed by the entire industry. And this is what Keysight is working on. As a track record, Keysight has been one of the main contributors of the ORAN conformance test specification with 60% of the content in it.
Yes, so you've been playing a big role. Do you think we have all we need to get all this, the analysis, both at the end-to-end level and at all the way down to the sort of chipset level? Are we there yet? So it's not just a question of having, again, basic interoperability. Do we have a way to test for power energy efficiency?
I think we have a good start. There is definitely quite a bit of innovation that it's still ahead of us as an industry. As we pull the data, we start getting, information, insight from the first round of experiments. We're gonna learn how to progress that. So I would say there is definitely the awareness and the desire and the need to progress in this area. I see finally the right level of attention to this topic in the standardizations, and experiments are being set up both in the lab and in the live operations. So I would say that definitely we have a good start, and we have a path in front of us that we need to follow.
Now, another dimension is basically services or types of traffic. So, at the very beginning, you just test for voice, then it's voice and data. And now we want to understand better what is the performance for different services. Now, that would be also interesting to know what the energy efficiency is for different services. So not just, clearly you want to have, at the end of the day, you want to know how efficient is your network in the end-to-end. Then you want to know what the different parts of your network are doing. Then there is hardware, then there is software, but also there is services. And for instance, when you have a network slicing, how do you measure it? Because network slicing comes with a cost in terms of resources. So that means more energy at some level. So how do we think about it, and how do we measure that?
Yeah, so if you want to measure, that's definitely one of the typical demands that we get. So how can we measure the energy efficiency into conditions that are representative of the real world? So that could be a typical life in the day of a radio station, where you have multiple load levels between the night and the day, the busy, the full load, or you could have different types of services that are being run to the base station. And here, we can leverage from test platforms that have been used to characterize the performance of those systems under these different types of traffic profiles. When we start playing into the energy plane, what we call the E plane, what we do is that we time correlate those measurements together with energy measurement. So as Giampaolo said before, it needs some level of cross-domain expertise where you combine traffic profiles with energy measurement. And the insight that you get is as you can correlate the traffic execution with the energy consumption. And then you can get a model that is very representative of what your system can do in the real world.
Absolutely. That's,
I would say, Monica, adding to a little bit of color to what Jean said, that we start seeing that as insights are emerging out of this type of measurements, operators are looking at this as a business and a monetization opportunity. For instance, a one vertical slide, a slice of the network could be an offering where the customer can get to decide what type of trade-off they would like to see between performance and consumptions, because that could translate in different pricing tiers. So that's something very interesting and exciting, because you bring the awareness of the consumption, the energy consumption, down to the end customer level. Yeah,
which is really important, because clearly you not only need to be able to support the services, you need to know how to price them.
Exactly.
And also, does the pricing that you can provide given the energy consumption match the willingness to pay of the customer? Now, that also brings up another topic, which is private networks. So there is an increased interest in private networks. If you have an enterprise, how does the enterprise measure for energy efficiency?
So here, the test methodologies that are used for Open RAN can be leveraged for different type of deployment of the Open RAN, because they mostly consist of having the right probes to monitor the energy consumption together with the traffic and the level of load on the system. And therefore, the same test methodologies that are used for different applications can be leveraged on other use models, such as private networks.
Absolutely. Now, we talked a lot about the fact that there's a lot of learning that we need to do. If we look at it in the future, what do you think that we need to improve? There is more work to do and more opportunities to be more energy efficient.
I would say that I would definitely like to see some maturity in the level of benchmarks and specifications across all the different standard bodies that are at play here. 3GPP and ORAN being maybe the main ones, but also ETSI. So I think that's important, because that establishes a reference and a baseline, and then it can bring some of those comparisons that you mentioned before, and drives the type of right type of behavior. As I said, I definitely see the attention now into the standard bodies. Keysight is helping and contributing, but definitely there is still more to be done in this area.
Absolutely.
What we see is that the entire ecosystem is working on optimizing efficiency, from semiconductor to end-to-end solution vendors. And I think that what we can achieve is to make sure that all the potential gains that are provided by these different building blocks can be exploited to their full extent, and have what the industry is calling a full elastic network, where you have resources that are only allocated when they are needed. And I think that's the ultimate vision.
Yeah, well, Giampaolo and Jean, thank you so much for sharing your thoughts with us today. And so we have been talking about testing energy efficiency in wireless networks, and our conversation is part of a report on energy efficiency in wireless RAN and beyond, where we talk about all the different parts of elements that are essential to establish energy efficiency. And so thank you, Giampaolo and Jean, and all of you for listening to us.
Thank you, Monica, for having us.
Thank you, Monica.